Hello everyone, this is Prabhashri, Department of Mathematics, SNS College of Technology. So today we are going to see about your matrices and then an introduction. So first of all, matrices and determinants. First topic is matrices and determinants. So matrices and determinants are used to perform various arithmetic operations involving array elements, and then matrices are a rectangular array of elements that are represented in the form of rows and columns, and the determinant are calculated for a matrix, and it's a single numerical value has been computed from this array of an element. So the matrix representation will be in an alphabet. It's mentioned as an uppercase A. We used to mention a matrix in only in uppercase capital A, and the determinant is represented as a modulus of A. We find out the modulus of A for to find out the determinants, and matrix determinants have difference in their properties. So the multiplication of a constant value k with a matrix multiplies for every element of the matrix, and the multiplication of a constant k with the determinant multiples with the element of any particular rows or columns. So let us know about what is meant by matrix and their properties here. So let us see about introduction. So what is meant by matrix? A matrix is an array of element represented as row and columns. Determinants are considered as scalar factors of a matrix. The matrix is generally noted by a capital alphabet. The order of a matrix is represented by rows into column. So a row is mentioned by M and the column is mentioned by N. So we are having a matrix in the order of M cross N, where M mentions the rows and N mentions the columns here. So here we are having one example matrix, that is 0 1 6 and 7 8 4 3 6 9. So the value of the position of 0 is mentioned as A11 and 1 as A12 and 6 as A13. It represents the first row having the first column and then second column, and represent with the third column like that. So matrices is generally denoted like this. For example, capital A equal to in the set of A small I j M cross N. M cross N denotes how many rows and columns are occurred in this matrix, and A I j means position of the elements that are presented in the matrix. So A11 means the position first row with first column, and A23 or 32 means third row with second column and second row with third column, like that. So we are having some examples here. If A equal to 2, 3, 4 and 6, 7, 9, the matrix is in the form of 2 cross 3. There are 2 rows and 3 columns. So we should write this matrix as a 2 cross 3. So the position of A11 is 2 and A21 is 6, and then A12 is 3 and A13 is 4, like that. Now we are going to see order of the matrix. So the order of the matrix is given by M by N. There M denotes the number of rows and N denotes the number of columns of a matrix. Now we are going with the type of a matrix. Now we are going to see some basic properties in matrices. So first one is commutative law. For the given matrix, if they given two matrices, consider that as A and B of the same order. The applications only if the matrices are in the same order, we can apply addition property with that two matrices A plus B, which is equal to B plus A. That is the commutative law. And then the second one is associative law. So for associative law, we need a set of three matrices A, B, C of the same order M cross N. So we have A plus B plus C, which is equal to A plus bracket instead of B plus C. So the extension of a additive identity, let A be a matrix of a order m cross n and O be a zero of a matrix or a null matrix of the same order m cross n, then A plus 0 equal to O plus A, which is equal to A. So addition with the identity matrix, we will get the same matrix itself. In the other words, 0 is the additive identity of for a matrix. So the next one is extension of a inverse matrix. So A inverse is A plus minus A, which is equal to minus A plus A, which is equal to 0. So here a minus A is the additive inverse of the negative of a matrix A. These are the most wanted properties in the matrices. Then the scalar property is if we multiple element K with a plus b matrix, then we can write that as k into a plus k into b. Same like that when we add identity element I, so we can multiply with that a, means k plus I into a, which is equal to k into a plus k into I into a, like that. Thank you.